Imagine a world where factories can think, where machines not only produce but also learn, adapt, and make decisions for themselves. A world where sustainability is not just a dream, but a system powered by intelligence, artificial intelligence. But here's the challenge. While we talk about AI transforming industries, one crucial sector remains locked in complexity: biomanufacturing. This industry, the heart of biofuels, bioplastics, and life-saving medicines, still struggles to answer one simple question: why do things go wrong? Because even with millions of data points, our factories operate like black boxes. We see the outputs, but we don't fully understand the causes behind them. And that's exactly what we're going to decode today: how causal artificial intelligence or causal AI can open that black box and ignite a new era of sustainable and autonomous production. The global industrial sector faces a dual challenge: meeting the growth demands of almost 10 billion people by 2015 while drastically cutting carbon emissions. Traditional manufacturing still accounts for a quarter of industrial CO2 emissions. Industrial biotechnology, using microorganisms and enzymes to make fuels, plastics, and medicines, is our answer. It can cut emissions by over 60%. But here's the issue. When scientists scale up from lab to the factory, nearly 70% of processes fail. Why? Because biology is unpredictable. Such as unpredictable, factories rely on data, but most AI systems only see correlations, not causes. So, even if an algorithm finds that a certain raw materials leads to better results, we don't know why. Maybe it's the supplier, or maybe it's just the temperature that day. Without understanding cause and effect, factories can predict or control their outcomes. Now, imagine if the biofactory could think like a scientist, not just seeing patterns, but understanding why they happen. That's where causal artificial intelligence comes in. Unlike traditional AI that only predicts outcomes, causal AI builds a map of relationships: what causes what. It uses two main stages. First, causal discovery. It scans through all the data to find true cause and effect links. Then, causal inference. It predicts what will happen if we change one thing like temperature or oxygen flow. Think of it like giving the factory a brain that can ask, what if I adjust this? And then simulate the result before acting. This turns a bioreactor from a black box into a glass box: transparent, predictable, and intelligent. In real life, this means a factory can respond instantly, not reactively, but proactively. For example, when CO2 levels rise slightly, causal AI doesn't just trigger an alarm. It calculates the future effect, a 10% drop in product purity. Then, it simulates solutions and finds that increasing agitation speed by 5% will fix the problem without harming other processes. This is a precision control at a level we've never seen before, increasing yields, reducing waste, and saving millions. Beyond operations, causal AI revolutionized research too. Instead of running 2,000 of lab experiments, scientists can now simulate genetic changes to see which one actually improve production. This could cut R&D time by half and make bio-based materials more affordable than ever. Of course, innovation always faces obstacles. Causal AI is complex, data-hungry, and requires skilled experts in both AI and biology. There's also cultural resistance. Industries that are comfortable with the old ways may hesitate to adopt something new. That's why collaboration is essential. Through the Pentahelix synergy, connecting academic, business, government, community, and media, we can build ecosystems that support innovation. Government can afford incentives, universities can train new talent, and industries can provide real-world platforms for deployment. Together, these five pillars can turn causal AI from theory into practice, accelerating Indonesia's vision for a sustainable, intelligent industry. At its core, the problem isn't a lack of data, it's a lack of understanding. Causal AI can change that. It shifts our focus from asking what happened to why did it happen? And even what if we change it? By decoding the biofactory, we move toward a future where production is not only efficient but also sustainable, where machines and biology work together intelligently. The future of industry is not just smart, it's causal. And if we choose to embrace it now, we can lead this transformation from Indonesia to the world. Thank you.